So in lesson 4, you are going to be looking at 3 specific ratios that are going to lead us into our first lesson with trigonometry. So on Wednesday, you will most definitely need a calculator. I would suggest if you have your own calculator at home, borrow one with the keys, sine, which is spelled S-I-N on the calculator, cosine, which is spelled C-O-S, and tangent, T-A-N as abbreviations. That might be helpful. I don't have a classroom set of calculators, so having your own calculator can be helpful. But again, if you don't have a calculator, there's always the online calculator that you can use on your phone page using the Desmos scientific calculator. In the handout, whatever doesn't get done during class is homework. And so it's to your advantage to not only work through the problems quickly with a partner, but try to get as much of it done so that you get your work outside class as minimum. So starting with problem number 1. And again, if you don't have a partner, please pair up with somebody, again, groups of 2, for not to have 3s. And the first question is asking if I look at the triangles that are given, I consider the ratio of A over C and B over D. Do you think they're equal to each other, one's greater than the other? Explain your reasoning. We ended up probably independently, and then have a discussion with your partner when you're ready to provide additional information about this problem. Turn the video back on. So hopefully, when looking at this problem, you recognize the triangles are similar. And so as ratios, we're taking a leg divided by a hypotenuse. And as long as the A and B are corresponding sides and C and D are corresponding sides, the ratios should be the same. The key here is to recognize that the length of A and B are actually opposite the 20-degree angle, which makes A the shortest leg of the left triangle and B the shortest leg of the triangle on the right. So, for example, if I was doing a 3, a 4, and 5, since 3 squared plus 4 squared equals 5 squared, and I do a scale factor of 2, this would be a 6, this would be an 8, and this would be a 10. If I scale from 3, 4, 5 by 2. Again, since A and B are the shortest legs because they're both opposite the 20-degree angle, if I would compare the short leg to the hypotenuse and the little triangle on the left and the short leg to the hypotenuse and the triangle on the right, these 2 triangles actually give the same value. So if again I cross multiply, just to kind of verify that, 3 times 10 is 30, and 6 times 5 is also 40. So hopefully indicating that the triangles, the ratios are going to be the same because you're comparing the same 2 sides of similar triangles. All right, so in this lesson as well as future lessons, there are 3 terms that will get used a lot. Opposite side, adjacent side, and the third side being hypotenuse. Now the third side, the hypotenuse side, is the one that you should be able to identify easily, just because we've been working with Pythagorean theorem for so long. So I'd like you to go ahead and on all 3 of these triangles, please identify the hypotenuse and label that length with the word hypotenuse, or at least the letter H for hypotenuse. So hopefully you chose 16.29 for the hypotenuse, being the longest side, or the side opposite the right angle. In the middle triangle, hopefully you chose the 10 as the hypotenuse, again being the longest side of the right triangle, or opposite the right angle. And the last one, DF, is the hypotenuse. It's not labeled as a specific number, but it is the longest side. It's also opposite the right angle. Now the opposite and adjacent. Question is, okay, opposite of what, or adjacent or next to what? So when we're identifying triangles, opposite side, we're using the angle that's the non-right angle. So I'm going to go ahead and shade the 40-degree angle. And the reason I'm shading that is because the opposite side to the 40-degree angle is the side that didn't get shaded. So the 10.47 is the opposite side. And then the third side, the remaining side, is the side that's called the adjacent side. Now, that side is adjacent to the 40-degree angle or next to the 40-degree angle, and so is the hypotenuse. So there are actually two adjacent sides, but one of them already has a special name. So one of the things that we're going to be doing as we label these triangles is we're always going to leave the adjacent side for last. Because that way if we can identify the hypotenuse correctly and the opposite side correctly, then the third side has to be the adjacent. So in the last, we have two triangles. If you'd please identify the opposite side to the given angle and then the adjacent side. Turn the video back on when you're finished. So hopefully when we shade the 25-degree angle, the side that doesn't get shaded is the 4.2, that's the opposite side. And hopefully you have labeled the 9.1 as the adjacent side. In the last triangle, the 50-degree angle is the angle we're working with. So the side that didn't get shaded, that's the side that's opposite the 50-degree angle. And then the third side where the 6 is, that's the adjacent side. So why are we doing this? Well, because when we get to trig, the three ratios or three quotients we're looking for involve three division problems. And these are the division problems. Adjacent side divided by the hypotenuse, opposite side or leg divided by the hypotenuse, and the opposite leg divided by the adjacent leg. So you have to be able to identify the three sides of the right triangle correctly so that when we divide the two numbers, that those two numbers represent one of those three trig functions. So problem number 4, you would go ahead and complete the table based on the three division problems. When you finish with that, you will need to go back into its learning, and there's a triangle image located in today's outline in the lesson 4 content block. And if you click on that image, you will open up a page. It looks like this, called Ratios in Right Triangles. Actually, is lesson 4 for the materials we're using. And if you scroll down this to where it says tons of triangles, this is the app we're going to be using. If for some reason that app doesn't want to open up, there's another link for a GeoGebra app. And it's the same sketch. It's just, this is the material, the IM material, the company that we're getting the material from, or at least looking at it. And GeoGebra also has partnered with this company to create the lessons online as well. And it's asking you to use the slider to come up with the different triangles. And so you're removing the point on the slider to get the different angle measurements. And like this problem at the bottom of page 1, they're asking you to take the three numbers and come up with those three ratios. And again, you need to identify correctly which side is the opposite, the adjacent hypotenuse. So go ahead and finish off problem number 4, and turn the video back on when you're ready to continue. So in completing this, you have to complete the Pythagorean theorem to find out what the length of the hypotenuse is. So c squared would equal 145. So the length of that side is the square root of 145. And then for the other hypotenuse, it's going to be 1 squared plus 10 squared equals c squared. So that means the length of the hypotenuse will be the square root of 101. So adjacent leg divided by hypotenuse. So if I shade the two sides of the 4.8 degree angle, the 1 is the opposite side. The square root of 145, which we use Pythagorean theorem to find, that's along the side, or it's opposite the right, that's the hypotenuse. And the adjacent side is 12. So I'm going to go ahead and go through the first one, and then you can turn the video off if you've not completed it correctly, and complete the second one. So the adjacent side is 12. The hypotenuse is the square root of 145. So 12 divided by the square root of 145 is going to give me the answer of about 0.997. Please run this to thousandths, which would be 3 digits after the decimal point. For the opposite over hypotenuse, it'll be 1 over the square root of 145. So it's approximately 0.083. And the last one is the opposite over the adjacent, so we have 1 over 12, and that's going to be approximately 0.833. So again, if you go ahead and finish off the next problem if you've not completed it. If you have, then go ahead and move on to problem 5 and open up that app in your Instagram account. So for this one here, the 5.7, if I shade that angle, 1 is the opposite, the square root of 101 is the hypotenuse, and then 10 is the adjacent side. So it's going to be 10 divided by the square root of 101. So it's approximately 0.995. And then it's going to be 1 over the square root of 101. And that's going to be approximately 0.100. And the last one is 1 divided by 10, but actually comes out to be exactly 0.1 or 1/10. Again, you want to write that in the thousands, you can just simply put 2 zeros after the 1 to turn the number into thousands. So in this problem, you're going to complete the table. This is going to take you some time. And then it's going to ask you to compare two rows, 20 to 70. Problem 6, what's the same, what's different? When you and your partner are completing this table, work together on the table. If you want to use 2 computers to speed up the process, great. If you want to use 1 computer and just simply work together to come up with the answers, that's perfectly okay as well. But when you get to problem 6, I'd like each of you to independently write down your ideas of what you see to be the same, what you see to be different, and then share those ideas, validate those ideas if the person doesn't understand or agree with you, and then at the end hopefully come up with a really good list. When you get done with problem 6, it's going to ask you again to discuss with your part of number 7. When you get to problem 8, it's going to ask you to look back at what you did in problem 5 and 6, and if I give you the 55-degree angle row, can you finish off 35-degree angle row? Or what if I gave you 0.839 as being the value for the adjacent side to the hypotenuse, which is the first column? Can you identify what you know about that triangle? So that number might be in the table, and it may not be in the table. If it's not, there's a lot of angles that have been left off. So what do you think that 0.839 is telling you about this particular triangle? Now, the one thing you're going to, again, I'm not in class, so I'm giving you more information than I would generally give you to begin with, but the last one, the opposite divided by the adjacent, that's going to be the tougher one to find patterns for. You're going to probably hopefully find the first 2 columns will be a little bit easier to see some patterns. So what I want to have you do is this. In terms of this last column, when you get to problem number 8, how do I figure out that answer if I already know the first 2 answers? Is there a way of coming up with that? So this is what I'd like you to do. I'd like you to go back and think about the first column, adjacent divided by hypotenuse, to be A, and then the second one being B, and the third one being C. And in the next video I will continue this discussion.